Hello, my name is MD Mahin and my student ID is 266462001, and I'll be presenting my project for IES, a cashierless automated billing system for small retail shops in Bangladesh using yellow object detection running on a Raspberry Pi 4. I would like to walk you through the problem we're solving, how the system works, and why this qualifies as a complex engineering problem. So let's check the outline of our today's presentation. I'll start with the problem, then look at why existing solutions don't work, introduce our approach, walk through the system design, explain the hardware and software, map the project to CPE criteria, and finally cover our timeline and success metrics. Let's start with the problem. Bangladesh has over 6.5 million small retail shops. Every single one of them depends on a human cashier to manually calculate and process each bill. This is low. During peak hours, billing one customer can take 2 to 4 minutes. It also can cause error. Studies suggest around 40% of small shop billing involves some form of human error, and it's expensive also. A cashier costs the shop owner around 5 to 10,000 taka per month, which is significant expense for a small business. Barcode scanners exist, but they still require a manual procedure. That's not automation. That's just a fancier pan. Before proposing our solution, I looked at what's already out there. Amazon Go is the gold standard. It uses cameras, sensors, and cloud AI to let customers just walk out without checking in. But it costs over 1 million US dollars to set up. That's completely out of reach. Barcode scanners are affordable, but still manual. RFID tags need tag attached to every single product. That's an outgoing cost. Cloud Vision APIs need internet, which is unreliable in many parts of Bangladesh. Our system, Yellow running on a Raspberry Pi, gives us detection accuracy of over 90%, cost about 10,000 taka as a one-time purchase, and work completely offline. The last column says best fit, and we believe it is. So, what exactly is our approach? In one line, a camera watches, the AI builds, and the owner profits. More specifically, a Raspberry Pi 4 with a USB camera runs a yellow version 8 Nano object detection model entirely on the device. When a customer places products in front of the camera, the AI recognizes each product in real time, looks up the price from the local database, and generates a complete bill on the touchscreen, all within 5 seconds. No internet needed, no cashier needed. Also, there is no subscription fees. Just one-time hardware cost of approximately 10,000 taka. So, let's see how the system works. The architecture has 5 stages. Stage 1. The USB camera captures a live video feed at 30 frames per second and sends it to the Raspberry Pi. In stage 2, each frame is passed through the YOLO V8 Nano model, which runs at approximately 20 frames per second on the Pi. It identifies every product it can see and assigns a confidence score to each detection. In stage 3, a confidence filter discards any detection that is below 85%. This prevents false positives. In stage 4, confirmed detections are sent to the local SQLite database, which returns the name and price of each product under 5 seconds. And in stage 5, the billing engine renders a complete bill on the touchscreen. On the software side, the entire system runs in Python 3.11 on Raspberry Pi OS. OpenCV handles the camera capture. The Ultralytics YOLO v4 library runs the detection model. SQLite 3 manages the local database, and the PySimple GUI provides the touchscreen interface. The flow is OpenCV captures a frame, YOLO runs interface on it. On the software side, the entire system runs in Python 3.11 on Raspberry Pi OS. OpenCV handles the camera capture, and the Ultralytics YOLO v4 library runs the detection model. SQLite 3 manages the local database, and PySimple GUI provides the touchscreen interface. The flow is OpenCV captures a frame, YOLO runs inference on it. Low confidence detections are filtered out. Duplicate detections across consecutive frames are removed. SQLite is queried for each product's price, and the bill is rendered on the screen. For model training, we use Cloud Collab. It provides a free GPU, which is necessary for training. And once the model is properly trained, its weight file is copied to the Pi. Now, let me map the project to the 7 complex engineering problem characteristics defined by IES. The first one is depth of knowledge. This project requires machine learning, embedded Linux, computer vision, database design, all beyond introductory level. Then the second is conflicting requirements. We had to balance cost versus accuracy, speed versus offline operation, and simplicity versus scalability. The third one is depth of analysis. No off-the-shelf solution exists for this specific context, so we had to design the pipeline from scratch. Fourth, familiarity of issues. AGI for retail billing is a low resource environment like Bangladesh is a novel and infrequently studied problem. Fifth is applicable codes. There is no existing IEC or Bangladesh standard for AI-based billing system, so we had to define our own validation criteria. Sixth, stakeholder diversity. Shop owners, customers, product suppliers, and other faculty panel all have different and something conflicting expectations. And seventh, independence. The hardware, air model, database, and UI are all tightly coupled. If the model performs poorly, the entire system fails regardless of how good the database or UI is. Our implementation plan spans 8 weeks. Weeks 1 and 2 are dedicated to dataset collection, capturing and labeling at least 200 images per product class. Weeks 3 and 4 are for model training on Google Colab, targeting a minimum MAP of 90%. Week 5 is edge deployment, getting the trained model running on the Raspberry Pi. Week 6 is the database and billing logic. Week 7 is the touchscreen UI. And week 8 is full integration and testing, ending with a live demo. We have defined 4 quantitative success metrics: detection accuracy of at least 90% measured by MAP at AOU 50 on our held out test set, billing speed of under 5 seconds from the moment the customer places the item in front of the camera, a false positive rate below 5 per session. The 100% offline reliability. The system must function without any internet connection for extended periods. These metrics are specific, measurable, and directly tied to the real world requirements of a shop owner. To summarize, we have designed a low-cost offline camera-based billing system purpose-built for small retail shops in Bangladesh. This is a one-time investment of approximately 11,900 taka. This thing is fully offline with no outgoing subscription and a clear path to extend it with receipt printing and mobile payment integration in future. I would like to thank Dr. Chaudhary Akram Hussain sir for the guidance, and I'm happy to take any question in the comment section. Thank you so much for your patience.